Hello, welcome back. In this segment, I will elaborate more on the in-order traversal of parse trees. Let us consider a simple example. Let's say you are given a parse tree like this, right? An AND operator here. You have a left subtree made of only one child, say P, and then a right subtree made of just Q. This expression is nothing but P and Q, right? Okay, so how did I get P and Q right away from this tree? I did an in-order traversal. I went to the left subtree, which has only P, okay? And then I came to the root, which is the operator. And then I went to the right subtree, which is just only one element here. Therefore, this is the linear representation of the tree. Okay, so we need an algorithm now. Given a parse tree as an input, yeah, this is the parse tree. Suppose somebody constructed a parse tree. We would like to traverse this parse tree and emit the linear representation. Okay, I'll show you an algorithm. It's fairly simple. In-order traversal means traverse the left side, traverse the root, traverse the right side, right? When I say traverse the root, basically print the value of the root. And there is an exception to that, right? What about, for example, not P? A not P would have, this is a not, right? And a P. In-order traversal definition means go to the left subtree, print the root, right? But if you do that, you'll be printing P and then a not, which is kind of awkward. So we need an exception whenever the operator is a not operator. Whenever an operator is a not operator, you would first print the not and then go ahead and print the traverse the left subtree or right subtree. Not will only have one of the subtrees. So that's an exception we need to track for the not operator. So how do we model this in a computer program? I will show you this now. I'm using this application, right, that allows me to run Python code online. So let me show you that. So you can see here, I have modeled the node as class node, and I have left child, right child, and the value, right, and the type. So there are four things associated with the node. How do you model a node? A node has two things, left child, right child. So this is the left and right. It's initially assigned to null because or none, there is no left or right at the beginning. And there is some value here. The value could be an operator or an operand. So we need to distinguish whether it's a, say, for example, a node has an operator like an AND operator, or a node has a concrete value, like, for example, suppose I have a concrete value here, like a P. So we need to distinguish whether this is an operand type or an operator type. That is the reason why I have introduced a type as part of the node. So node has left child, right child, value, and the type. That's how I model a node. Okay. And now we go further down, right? How am I printing the tree using in-order traversal? So what I'm doing here is I'm using recursion to traverse this. As you can see here, first I check whether the current root value is a not. If it is a not, right, I would go ahead and print the value of the root. And then I check whether the left child exists. If it exists, I go ahead and print the left child recursively. Otherwise, I check whether the right child exists and print it. Remember, not is a unary operator, so you cannot have both left and right child. So that's the reason why I have an if then else statement. Okay, what if the root is not a not operator? Then I check what type of node is it. If the root type is an operator, okay, an operator means and or implies in our case, then I open a parenthesis, perform the in order for the left, okay, perform the in order for the left, and then print the current value of the root, and then perform the in order for the right. Essentially, this is it. This is how I am traversing my tree. So where am I building the tree? As a proof of concept example, I need to build a tree. I built the same tree that we discussed during the previous segment, right? I have something here. As you can see, I start my root node to be the node I implies, which is clearly an operator type. And then I create a left node, which is another operator, right? And operator. And I continue all of those. I keep building the entire tree using this root dot left, right, and so on. It's a small tree, so I can easily build it with a few instructions. Okay, now if I execute this, right, you would see something as an output, and I'll show you what it is. It is nothing but the tree that you're seeing. Not P and Q implies P and Q are not R. That's essentially what I have built here in my root, starting from implies, and I'm applying in order traversal over here. You can see here, this is my call to the print in order function. Thank you for your attention.